Yeah. So kind of last minute, I wanted to talk about this today because I skipped out on Orlando Code Camp to do a personal thing because I think personal stuff is important too. And so I'm like, well, I have this talk kind of in the can, and I want to talk about it in Orlando. So if anybody didn't get a chance to go see me at Orlando Code Camp, maybe we'll talk about it tonight. So it's really informal and it's not super polished because I kind of like switched out all the technology last night. So I feel like a mad scientist. I feel like I'm sort of like Miles a little bit. Like I feel like I'm touching your greatness. I'm like getting close to it because I feel like you're just like a mad scientist who just walked.
I've failed 100 times more than I've succeeded.
And I think that's part of the mad scientist vibe. And I think that leads to learning. So rather than just having a super polished talk about something that's really perfect, I'd rather just talk about how this process is extremely messy and awful and whatever, but also really fun and exciting. So I'm going to talk about connecting my 1988 Ford Bronco II to the internet. So I bought this piece of crap for $750.
Well, that's the OJ edition.
No, this is the little one. He drove the full size one. So this one you only get 10 years. The full size one you get 20. So anyway, it's a little OJ joke. So I bought this for $750 from some guy on my street, and when I bought it, not everything worked necessarily, including the coolant temperature sensor. And so having an unreliable coolant temperature sensor and gauge is a fun experience if you like stress and or worrying about if you're going to make it anywhere. And so it was literally pegged at H the entire time I drove it. And I said to myself, self, how do I remedy this? Let me go down to AutoZone, give $20 to the nice people at AutoZone, get a little gauge. This is the replacement gauge for the original. And it came with a sensor, it came with like a couple different sized, whatever.
Pigtails, connectors?
Yeah, sure. Put it in the block, read the temperature, whatever. But the cool thing about this gauge, / the amazing thing about this gauge is that it's not digital, it's analog. And what it does is, the engine block and the coolant literally heats up a gas, and the gas gets pressurized, and the pressurized gas pushes this needle up to whatever temperature it is, which is really clever and really inexpensive, which is why I could pay $20, but it's also really not all that accurate. So I drove around for like 10 minutes every day, and it would sit at 0, and then all of a sudden it would jump up to like right about here-ish, and I was not satisfied. And so this is the reason I kind of started going down this rabbit hole of how do I solve this problem? Now, a rational, normal, average human being might say, well, there's obviously, Jared, there's solutions out there. You could fix your original gauge. You could buy a more expensive gauge that's a digital gauge that someone has already paid the money to get manufactured and paid all that time to engineers who know what they're doing to get an accurate reading. And I think that something's wrong with me because I said, you know what, no, let's spend hours and hours and hours working on an IoT project and dollars and dollars and dollars on all the random pieces of hardware that I need to get shipped from weird places like Italy and fix this problem in a way that's going to take months and months. And I don't really know what temperature it is during that time as I drive around my Bronco. So that's the reason why I made the idiotic decision to try to fix this problem myself. We'll get to it. But this is the reason behind the reason. Because if that was really the reason, I would truly be an idiot. But the reason behind the reason is that I really am passionate about DevOps. That's what I do. That's like what we do at the work at my job every day. And I wanted to be able to figure out like what are the DevOpsy things that are in IoT that I can focus on because I'm really passionate about IoT and I'm really passionate about DevOps. So how do I put the two together? And then how do I apply it to this little project to kind of learn about not only solving the problem at hand of reading temperature, room temperature, but the process of delivering updates to that device and things like that. So those of you who aren't familiar with DevOps, it's kind of like smashing together these two roles in organizations, development and operations. So traditionally, like in the 90s, let's say, they're in big organizations, these two are very separate things. Then over time, we've realized that when they're separate, there's a lot of infighting. There's a lot of issues. So the idea is if you put them together, those roles, not necessarily the people, but the roles, you development, the people who make the code, and operations, the people who keep the code running. If you put those two roles closer together, then things can happen faster. So that's kind of the term DevOps and how it came about.
Oh.
Wow.
I think it might be outdated. I made this a little bit ago. Is it outdated yet? It should be. So basically, the idea of DevOps is that you have a cycle of delivering value in software. So there's different things that happen in that cycle. So you plan, and then you make something, and then you test it, and then you deliver it, and then you realize the way you deliver it isn't anything like what someone was asking for, and so you go back and plan again and then change it. And so this happens a lot in software development on the web, and I think that this also happens a lot in IoT. It's just people who are like embedded developers don't necessarily think about this process traditionally because they've built something once, they need to make sure it really works, and then they ship it, and then they never touch it again. So as those embedded developers get into connecting their stuff to the internet, you really need to think about, how am I going to update this thing? How am I going to keep it running? How am I going to know that it's up and running, and what happens if it stops running? You brought up some interesting points earlier. You said, hey, if this thing gets bricked, what do we do then? And so you're like half and half buckets of, so Mongoose is thinking about this problem at the extreme low level in real-time operating systems. So I want to think about this problem too, but I'm a silly C# developer, so I don't get to play it quite at the low level you get to play at, or at least I could, but I wouldn't know what I'm doing yet. So I use this project to kind of, we'll skip this slide, to examine this process because, like you're saying, who wants shoes from the future if they don't work, right? Like we all want
shoes.
We all want really cool shoes that self-lace, but the risk is that someday they might not work, and that's a really bad risk. So if we can reduce that risk to almost zero, like of course we would all want shoes that lace themselves if they also charge themselves. But anyway, that's a whole other thing. So I just want to say, like, that's a real problem in the real world, like that people are thinking about. Like, how do we make sure that we can update these devices in a reliable way? And because we'll need to think about that. So I really want to think about continuous delivery specifically in this project. And I thought about it as a web developer, and usually we build, we test something, we throw it at the cloud, and then eventually, once we get it into the cloud, it's fine, it's done. Millions of people can see it. Same thing with app development. We build it, we test it, we throw it at a store, and then millions of people can see it. But IoT development is less clear because we have these millions of devices, and there's not really an intermediary. We are the intermediary. We have to figure out, how do we get our code to those millions of devices, or in this case, one Ford Bronco. But the example is that I want to understand how to get to those millions of devices. So what is that question mark? And when I started looking at these choices, like how do we deliver code? I realized there's a few categories. So we have the homegrown option, which I think this photo illustrates how well that goes. Like, if you throw something together yourself, you're retreading what many other people have already figured out. So forget this. Don't try to build your own system of delivery. Then there's off-the-shelf systems like Particle Photon. Particle Photon is like a little device. They sell devices, but they also have a cloud backend, and they work together really well. So if you deliver your code to their cloud backend, they'll take care of distributing it to all those devices. And that works really well. There's some pros and cons. The pros are you don't have to worry about it. The cons are you kind of buy yourself into a system. Particle hasn't been around forever as a company. They're relatively small compared to like Well,
Don't they have like, isn't there like Python or maybe even JavaScript? Because I think I remember, I backed them on Kickstarter.
yeah,
But don't they have some kind of UI where you can actually edit the code online?
in the browser. Yeah, you can edit the code in the
But
browser,
it's C++
hit save.
code at that point.
Yeah, C++.
Okay.
You can put your own firmware on there, like, there's a lot of things you can do.
It really looks like the Arduino IDE web IDE. In fact, it looks like Arduino's web IDE.
Okay, yeah, it's been a while since I looked at it.
And they want you to buy those devices because they want you to pay for them, and they eventually want you to sell 1 million of them to all your best friends. And that's how they'll make their money. And they make it really easy to get into it. But I personally think that the future of IoT, like, eventually is gonna roll up into the major cloud platforms just because they have so much money and so much development effort that they can put behind it. And I'm not saying like Mongoose OS, I'm not saying that's gonna go away because that's at the edge, but I'm saying like where that data is going from there, I think eventually is gonna be some major cloud for most people, and I'm not saying everyone. So I chose using a public cloud platform, Azure, because I'm a Microsoft diehard, and I'm not afraid to say it. And they do a lot of open source stuff, so they're
They're all right now.
yeah, they're all right now. They're all right now. They're paying their dues. They have some debt in that regard. So I was spoiled for choice on what to use. I chose Azure and as kind of like a back end. But more importantly, like I wanted to figure out how do we get code to the device. And I didn't really want to worry about it from like, I didn't want to burn my fingers, I guess is what I'm saying. I wanted to use like the child's playset version of what we're doing. So I decided to use tools that I'm familiar with. So I'm familiar with C#, I'm familiar with Windows, Microsoft Developer. And so I chose to use Windows 10 IoT Core as the operating system. And Windows 10 IoT Core runs UWP apps, or Universal Windows Applications, the things you'd find in the Microsoft Store if you ever go into that awful hellscape. So basically, I can take advantage of Microsoft's delivery platform. I can send my code in a nice little app to the Microsoft Store, and the Microsoft Store can update my device for me. I don't have to worry about the delivery.
Windows Update?
Using Windows Update, exactly. And I can update the operating system using Windows Update. So I can update Windows 10 IoT Core using Windows Update, and then, I don't know if it's Windows Update, but if Windows, see, that's the thing, I don't need to care. Microsoft takes care of updating the app for me. So there's a little weird workaround also.
Oh, yeah.
Anyway, there's this, yeah, exactly. So that's what I'm gonna do. So there's this weird workaround in Microsoft land where they say, okay, in your IoT device, you're probably not gonna have the Windows Store available. And even if you did, people wouldn't know to go into their thermostat and go into the Microsoft Store and find your app and download it and install it. So you need to pre-install your application. And so to be allowed to pre-install your application, you need to sign up as an OEM. So I did that. I signed up as an OEM. I am now an OEM. I can make my own images of Microsoft Windows 10 IoT Core, and I can put my own application within those images. So my application comes pre-installed on my version of Windows 10 IoT Core that I can pre-install on the device, and then I can get it manufactured, ship it out, it can sit on a shelf, somebody can go buy it, go home, plug it in. They don't even know it runs with Windows. It just boots up, shows my logo, shows my application as the only application that boots a startup, and their Ford Broncos, all of those people's Ford Broncos, run perfectly. But yeah, so this is kind of like the various tools that I used to build this thing. However, halfway through development, I came across a tidbit of information that I get the sense that Windows 10 IoT Core is being ignored by Microsoft. So I'm like, I think that it's like at a Windows 8 situation where everybody hates it right now, and eventually maybe it'll be a Windows 10 thing where people will love it again at some point in the future. But for now, Windows 10 IoT Core, I feel like Microsoft's like, nah, whatever. But they are putting a lot of money and time into something called Windows or Azure IoT Edge. which is a whole other thing. And I'm not going to get into it today, but that's what I worked on last night to switch it over to. And Windows IoT Edge runs on all sorts of things, including Linux. So I'm using Debian, which is an operating system for Raspberry Pi, to run IoT Edge, and I'm working toward running my code on it. And all of these things in principle still apply. I still want to be able to figure out how to update it, which I can do, and I still want to figure out how to figure out the DevOps of it. I'm just using different technology. So although I agree with all the things I just said about the Windows Store and Microsoft IoT Core and all those things, I think they're great. I also think the market right now is not loving it. So I'm like, oh, well, maybe I shouldn't waste my time on stuff people don't care about. So anyway.
So you still push it as an app though to the Edge?
It's actually a container or containers, and you put it. So Windows IoT Edge is a underlying daemon basically that runs on top of many operating systems, including full-blown Windows, Windows IoT Core running on x64, but not ARM32, full Linux of many varieties. But anyway, it runs on top of an operating system, and it acts like a support system for your containers that you want to run on top of it. And you put your containers on top of it, and they can send messages across a message bus to each other, and eventually probably to the cloud, although you don't have to. And the way you update it is you send your images, hopefully through a CI/CD pipeline, into a container registry. And your device looks at that container registry and says, hey, is there a new update? Hey, is there a new update? Hey, is there a new update? And eventually there will be one, and it updates itself. So that's kind of like the whole process there. So anyway, let me show you what the heck this looks like in real life. So this is my device, and I kind of got stalled. Just to give you a time frame, none of this physically existed except for the Raspberry Pi and some plug-and-play sensors until last night when I wired all this stuff up and ran Raspbian and then installed the I2C controller stuff I needed to do and then read the temperature, and I was like, yes, I can read the temperature. Finally, I can not look like a sham in front of all these wonderful people at the IoT group. But basically, to give you an idea, my sticking point was this sensor. So this sensor is using a protocol called the one-wire protocol. It was on your list of things for Mongoose OS, by the way. I don't know hardware, so this is like where I fail most of the time. So this sensor is a temperature sensor, and the idea is that it screws into my engine block of my Bronco, which I'm hoping by the end of the week we can find out for sure if it does fit. But it reads temperature, and it sends data over this wire, and then I soldered more wires for length. And then it goes into this little piece of hardware right here, which converts it from one wire, which is a certain digital protocol, into I2C, which is another digital protocol. The reason being is that when I ordered this piece of hardware, I was running Windows 10 IoT Core. Windows 10 IoT Core does not speak to one wire directly. It needs to go through I2C. Because Windows 10 IoT Core runs at a higher level on the operating system. It's not as low level as Linux, in the sense that Linux can talk directly to one wire, and the drivers are not available for Windows 10 IoT Core to do the same thing. So basically, I had to translate from one wire, which is what is coming through these wires, into I2C so I can read the temperature. Well, after I bought the hardware and hooked it all up, or basically I realized I probably could just talk to this one wire directly if I'm using Linux, but yeah, whatever. So we hooked it all up, I put Linux on it, I'm reading it, I'm fine with it, I'm not touching it, it works. So eventually, now that I have all this hardware junk stuck together, when I put IoT Edge on here, or I have IoT Edge on here, but when I'm able to put the code I want on to IoT Edge on here, I can write the code to talk to I2C, and then I can read the temperature and then eventually send it to the cloud. So that's the whole project. I could demo it, but it's, really, I'm not sure if it worked, so, whatever. I guess I'll take questions about my crazy, awful, horrible, amazing trip. Yes?
Would you like me to show you how to do that in Mongoose?
Let me guess, it's really easy. So I think that it's really exciting in IoT right now because nobody has all the answers. And I think some of the stuff you showed me with your Mongoose OS demo and everything, I was like, wow, that's a really good idea. And there's so many real-time operating systems out there, it's just like a plethora. And then Microsoft, because I'm a Microsoft fanboy, they're coming out with like Azure Sphere, which runs a version or a flavor of Linux. And the whole focus, a flavor of Linux that Microsoft created, which is really crazy. It's the first time in their history they've done that.
Embrace, extend, destroy, is that how it works? I forget.
Extend and extinguish.
Right. Extinguish.
Extend and
Trees.
extinguish. Yeah, I hope they don't do that anymore. We'll see. I don't think that's their thing anymore, but.
I think for years though, it's because you're gonna have it, I'm sure you're gonna have more than just that
Yes.
eventually, so you're gonna have a
Yes.
lot more stuff, so having it on like a
Exactly.
small microcontroller wouldn't
Right,
really make sense.
right. So I think, exactly, I want to do vision eventually.
Yeah.
Eventually, I would like to read license plates, run it through OCR, and run it against a API that does, what's the Amber Alerts, to find out like if the people around me are
Oh,
stealing
okay.
children or something.
Yeah.
Cool.
Eventually, you guys are like, wow, that's amazing. It's just an idea, haven't done anything on it, so, whatever.
Talk to your
But-
lawyer about it before.
Talk to my lawyer about it, probably a good idea. But as I was saying, like, I think IoT is really exciting because nobody has all the answers yet. We're still figuring things out, and I think there's a lot of different operating systems out there. There's a lot of competing ideas about cloud backends and how they should connect and what makes things secure and how do we update and all those things. That's why I really love the space, because we haven't figured it all out yet.
What are you gonna use for display?
So originally, UWP has a nice user interface stuff already built in, and I was going to use a connected, little connected display. I don't know how IoT Edge works with communicating with the user interface yet. I may bypass that whole thing and eventually make an app for my phone that talks over Bluetooth, but that's really, I just want to get it through the cloud right now. So the user interface is kind of secondary for me right this second. Eventually I want to figure that out.
Do you need to read that?
You need the temperature.
Yeah, exactly. The temperature needs to be
Somewhere.
shown somewhere. And the question is the delay in communicating with the cloud long enough for it to matter on whether my engine's gonna explode or not? So, yeah, that's the question. And if it's no, like you said, which you seem very confident about, which
I'm just
I'll bring you
thinking the thermal mass of an engine, you can't
You guys
change
think, are you gonna
things.
get internet on it too? Are you gonna?
Oh,
cell service or something?
Yeah, for now, I'm just gonna run it through my phone.
Yeah.
I'm just gonna have a hotspot on my phone as I'm driving around. In the future, I'd love to move it off the Raspberry Pi and start figuring out what other options there are that might have LTE built in them, or especially because there's a lot of stuff around security that the Raspberry Pi is not very helpful with. There's TPM, Trusted Platform Module, which Microsoft is, I don't know. I listen to one central source of information, which is why I'm really happy to come here to hear alternate ideas.
That's what ulterior motives too.
Ulterior motives, alternate ideas. So they call it Trusted Platform Module, but it's basically a hardware root of trust.
Yeah.
So, and I think there's different names for it, but basically there's a chip in it that says hey, I have this number and it's cryptographically secure, and this is the hardware it's attached to, and that is something that the Raspberry Pi does not have, and other devices do have. And so I'm eventually when I'm done prototyping, I want to start looking into how do I move this into something that's secure? How do I move this into something that I can connect to the internet without me using my phone?
Yeah.
Do I have to design something? Because that would be exciting, and also I probably wouldn't be successful at it, but it'd be fun to look into it. So
That's what I was mentioning
Yeah.
at the end too, is that the secure, so the ESP32s have one of those built into it, but the
Oh, really?
8266s do not. So
Oh.
you'd actually have to put that on extra. So, with the Mongoose OS stuff, I think that's more for, if you're looking to build a device for less than $20,
Yeah.
Whereas, that would be the way to go. Whereas like your stuff, you'll probably need a full-blown, OS so that you can
Eventually,
manage this, this, all the different
Exactly.
pieces. And bring them together. Whereas I'm trying to be as cheap as possible so we can make
You'll
most
have to
money.
wait, you'll have to wait your gauge to boot.
I have the luxury,
Which will be no fun.
right now I have the luxury of like literally one device I have to buy. But once people get into like selling tens or dozens or hundreds or thousands, I don't know, how many devices you have out there right now?
Right now?
Yeah.
3.
Oh, well, how many
Yeah.
devices do you think you might have in like 3 years? If all goes well.
Well, hopefully thousands.
There you go.
But we'll see.
Yeah.
Yeah.
So I think people, like
I've
right
break it
now.
10 times first.
What's that?
I said I've had to break it 10 times over before. I get
And
to that
that's,
point.
that's fine, I think, obviously, you have to go through a process of figuring out what's gonna work. I think, like, I'm not at the point yet where scale matters, so
Yeah.
I can spend like $200 or $300 on the device, and it's not gonna be a problem, but if I were to try to replicate it for everybody out there who's got their 1988 Ford Bronco IIs, it would be a problem, because they made like 300,000 of them, and I'm sure they're all on the road still today.
I would imagine.
Yeah, of course.
Well, maybe you could just look at building your own in-dash, system and have it all built into that.
Use
Yeah.
the Surface.
Oh.
Yeah, there you go. I said $300 or $400, maybe $200 or $300, not
Yeah.
$2,300. But yeah, no, I love playing in this space because I feel like I learn a lot. So I mean, it doesn't really matter like if it works out or not. I've learned something and I'm happy about that. Like the hardware part of it, like with the sensor and trying to figure out finding a sensor that's waterproof and goes up to 500 degrees and can communicate to the language I'm using at a higher level. Like there's a lot of problems that I didn't think about before until I actually put it into practice. And so that's what I really like about the project. I'll take 3 more questions. 3 more. Nobody?
What are you gonna do if it does blow up before you fix it?
Oh, I don't know, throw it away. Leave it in your yard, I don't know. I mean, I don't really think it's gonna blow up, cause it's got coolant in it and it does what it needs to do, but that's just a fun risk I'm willing to take. It was $750, the whole trick, I'm sure I can scrap it and get.
I understand if you take the hood off, it cools better too. but-
Yeah, there you go.
Saw it on YouTube.
What about the heat around the wires too? Have you had any issues with that?
Well, I haven't plugged this bad boy in yet, so we'll find out. I'll let you know.
Yeah.
I'm worried about interference a little bit because the one-wire protocol is low power by nature, and having this in an engine with a bunch of electrical stuff going on, I'm kind of curious if that'll affect it. But because it's digital, it should be pretty obvious if it affects it. It's not analog, and I don't expect like a bunch of noise. I expect it either to work or not work. At least I hope that's how it works, or it doesn't work.
Does the Raspberry Pi support the one wire on one of the GPIOs natively?
It does. I mean, it does in the sense that if there's literally a click button in Raspbian for turning on one-wire support.
Okay.
I was using Windows 10 IoT Core,
Mhm.
and that doesn't have one-wire support natively. It sort of does, like if you use like a Schottky diode and you wire it up right, but then it's like super not reliable, and I'm like, okay, let me just
Probably
make it
a
reliable.
kernel module, and it's probably all done in software, it's probably all bit bang anyway, so you can probably bit bang any GPIO you want.
You probably want to do it for reliability purposes, get the I2C out of it, just connect one wire straight into a pin, because to be more mechanically solid, you don't want too many things dangling. while
I
you're
mean, I
jumping.
agree, and I think, like I said, it's been a long road for me on the hardware side. Like the software side, I mean, it's fun.
Oh,
but the-
man.
What, a long road? What?
Have you had that in the trunk for a while, or?
Huh?
It's just, you're making truck puns.
I don't even realize it. That's
Inadvertent
amazing.
truck puns.
Inadvertent. That's awesome. I really should
We'll even
be
talk
more
about your-
aware of my puns I'm making.
Your pursuit of perfecting.
I think it's
Bronco.
become part of me now. Like,
Are you just getting started, or?
is that fun? Is that fun?
Stop.
All right.
Put the brakes on when you can.
Stop jumping around. Wow. All right. Anyway, I really do enjoy puns, but because I wasn't aware I was making them, I feel like I may enjoy them too much, and now I'm reliant on them as part of my natural language, which bothers me. But that's it. I'm okay. But anyway, so that's my thing, and eventually, hopefully you'll see another talk where I have more stuff in vehicles measuring real things, but I stuck the sensor in a glass of cold water and it seems to measure right temperatures, so I'm happy so far. Cool. Oh, wait.